how to plot the polar plot. Polar plot is basically open loop frequency response plot. So we have to take the open loop transfer function. Let us see what are the different types of open loop transfer functions we have. So to draw, I can classify the transfer function as minimum phase transfer function and a non-minimum phase transfer function. To find the stability of the closed loop system using polar plot, we use gain margin and phase margin, which means the concept of gain margin and phase margin is used in the polar plot to find the closed loop system stability. Therefore, polar plot is applicable only for minimum phase transfer functions. The minimum phase transfer function, all the poles and zeros must lie in the left of the S-plane. So if you just take finite poles and zeros, you may have the poles at origin, but finite poles and zeros, they must lie in the left half of the S-plane. Then only we can say that open loop transfer function is minimum phase open loop transfer function. So therefore, to find the stability or to use the concept of gain margin, phase margin, the transfer function must be minimum phase transfer function. But we can also draw the polar plot for non-minimum phase transfer functions, but we cannot apply the concept of gain margin and phase margin. So in that case, we use the Nyquist stability criterion. So Nyquist stability criterion is very powerful technique to find the stability of any type of open loop transfer function. It may be stable, open loop unstable, open loop stable, minimum phase, non-minimum phase. Any type of open loop transfer functions, we can find the stability. And to plot the Nyquist plot, we need polar plot. So polar plot is a heart of the Nyquist plot. Therefore, Nyquist plot can be drawn for both minimum phase and non-minimum phase open loop transfer function systems. Minimum phase transfer function without zeros. So whenever you have an open loop transfer function, that is a minimum phase, and if there are no zeros, then a polar plot will be very simple. Let us see how to get the polar plot. Now whatever the polar plot we get here, that is the approximate polar plot. If you want to get the exact polar plot, then we need the polar graph sheet, and also we need to have all the points for various values of omega, magnitude and phase angles we need. But to find the closed loop system stability, or to use the polar plot in Nyquist plot, so approximate plot is enough. Now the steps are like this. So first step is look at the open loop transfer function. Then the open loop transfer function GH of S, it is a minimum phase, and also there are no zeros at all. Then substitute S is equal J omega. When you substitute S is equal J omega, it is a sinusoidal transfer function GH of J omega. Write the magnitude expression and as well as the phase angle expression. So these two expressions are available. Now prepare a small table where you have 3 columns and 2 entries. So what are the first column is omega, magnitude and phase angle. So I want to take omega 0, which is the starting point of the frequency, omega infinity is the ending point of frequency. At these two frequencies, let us find out what is the magnitude and phase angle. So magnitude is it is m naught. So m naught is the starting magnitude. Then the phase is f naught, means we have phi naught is the phase angle of the corresponding omega is 0. So that I can call it as a starting angle. So starting magnitude is m naught, starting angle is phi naught. When omega is infinity, m infinity is the ending magnitude and phi infinity is the ending angle. Then how to get these two? So once the transfer function is available, look at what is the type and what is the order. From the type and order, then we can easily find what will be the starting angle and ending angle. So let us say what is the starting angle phi naught. So we can write in formula wise, phi naught is equal to minus 90 p naught, where p naught is the number of open loop poles that are there at the origin. That means origin poles. So minus 90 into p naught. If you have one pole at origin, the angle will be minus 90. So one pole means it is type 1. Whenever you have type 1 system without no zeros, the starting angle is minus 90. For type 0, it is 0 degrees. So likewise type 2, it is minus 180 degrees and so on. So depending upon type, then I can directly tell what will be the starting angle. Then what is the ending angle? Ending angle formula wise I can write So minus 90 into P. P is the total number of poles. So if total number of poles are 3, then ending angle is going to be minus 270 degrees. So this P is total poles, which is the order of the system. Therefore, the order gives the ending angle, type gives the starting angle. Then what is the starting magnitude M0? When you look at starting magnitude M0 for type 0 system, when I take only type 0 system, there will be a point on the 0 degrees line. For type 0 system, M0 is always a point on the 0 degrees line. Then what is M0 for other types, type 1, type 2, type 3, the M0 is going to be infinity. So M0 two cases, one is a constant value on the 0 degrees line, the other is infinity for all other types. Then what is M infinity? That is the ending magnitude. The ending magnitude is always 0. So ending magnitude we know, and ending starting magnitude and ending angle and starting angle. With this information I can easily sketch the polar plot. Now look at the graph sheet. So without having any circles and phase angles, then I can have x-axis where the other side is 0, and this is minus 90, this is minus 180, minus 270 as the y-axis, and it is origin. Now, so the end, what will be the starting and ending things depending upon the type and order. The starting magnitude for all the types of system except type 0 is infinity. Therefore, for type 1, when I say it is coming from infinity, and when it is type 1, what will be the angle? The angle is minus 90 degrees. So minus 90 degrees line, and here the starting point of the polar. So here it gives the type. This is type 1, and this is type 2, this is type 3, this is type 0. For type 0, you will have a point, but the phase angle will be 0 degrees. For type 1, it is infinity, but the corresponding line is minus 90. So again it is type 2 and type 3. So all these the ending infinity points are types, which is the starting point of the polar plot. What will be the ending point? The magnitude wise ending point is always 0. But when it is approaching to 0, so it is going to take which angle? Which is a very important for me. That is the ending angle. So ending angle is given by the order. So this is the order 1, this is order 2, this is order 3 and order 4. When they are approaching, they are going to take the help of the order and corresponding phase angle. When it is starting, they are going to take the type number of the open loop transfer function, and they are going to from the either for infinity or from any constant value. So this is the procedure to plot polar plot for MPTS, that means minimum phase transfer function without zeros.